All right, here's the quick test problem. Remember, we're going with this idea that my force is equal to my change in momentum over my change in time. Of course, remembering that both of these are vector quantities. All right, so, and then also, if we know our force, then by Newton's second law, we can find the acceleration from F equals ma. Let's continue on with the conservation of momentum. The conservation of momentum is an idea that just says that the initial momentum of a closed system is equal to the final momentum. So we could say that the initial momentum equals the final momentum. When I say a closed system, that means that a number of particles that don't have forces acting upon them from an external source. So for example, let's say that I have two objects of the same mass, and they're going with velocities that are equal but opposite. Now, the momentum of this system would include the momentum of this particle and the momentum of this particle. Now, because momentum is a vector quantity, and these have equal masses and equal but opposite velocities, then the momentum of this system would equal 0. Now, if they collide, as they will, and they will then go in the opposite directions, then they're going to be such that the final momentum must be 0. So their velocities must be such that their final momentum is 0 because of this conservation of momentum. Since my initial momentum is 0, my final momentum must also be 0. All right, so in this case, they're going to collide and rebound with velocities that are equal but opposite. Let's do a problem, an example. Consider this collision. I have two particles. One has a mass of 3 kilograms. That's mass 1. Mass 2 has a mass of 4 kilograms. The initial velocity of mass 1 is 1 meter per second. And then the initial velocity of mass 2 is -2 meters per second. So I can figure out what is the initial momentum of this system. My initial momentum will equal m1 v1 initial plus m2 v2 initial. That's going to be 3 kilograms times 1 meter per second. Plus 4 kilograms times -2 meters per second. So it has a momentum, which is 3 minus 8, which is -5 kilogram meters per second. That means that the momentum vector, that it has a net momentum equal to -5 kilograms meters per second. And it's pointing to the left because it's in the negative direction. So that's my initial momentum. And I know that the final momentum must be the same. So I tell you here the final velocity of this ball is -5 meters per second. And now I want to know, well, what is the final velocity of this object? So I know that the initial momentum must equal the final momentum. I know that my initial momentum equals -5. And that has to equal the final momentum. Now the final momentum will equal m1 v1f plus m2 v2f. And I know all those values except for v2f. Let's see, m1 was 3 kilograms. M2 was 4 kilograms. And then if I want to solve that, I say -5 equals -15 plus 4 v2f. Just a quick hint. So when you're working through these, you need to be very careful with your subscripts, because if you get your subscripts incorrect, you'll come up with the wrong answer. All right, so 15 minus 5 is 10. So I know that the second particle has to be traveling with a speed of 2.5 meters per second. That's going to be in the positive direction or to the right. Let's work through another problem. This is going to be based on the Dodgeball movie. I have a clip I'll show you in just a second. You're going to pick up at about 3:15. It should fast forward to that time on its own, but if it doesn't, you can fast forward. There's actually some vulgar language prior to that, so you may watch it or wish not to watch it. But we're going to see here a clip where Peter LaFleur and White Goodman are involved in this dodgeball death match. And I want to know what is the initial velocity of White Goodman's ball when he throws it at Peter LaFleur. So as we're watching this, you need to think about what are the two bodies involved in the collision. And then for those two bodies, we need to know their masses and their initial and final velocities. Now, I want to know what is the initial velocity of the ball. And all of the other things we can estimate or measure fairly accurately. So let's go ahead and watch this. You can pick up this clip, as I said, at about 3:15. You can do it by clicking here. All right, so what we had here, there are two bodies. One is the ball. It has a certain initial velocity. All right, it has a mass, I don't know, a dodgeball, maybe 500 grams or a half a kilogram. I want to know what this initial velocity is. Now, initially, White Goodman has an initial velocity equal to 0. Right? And the mass of White Goodman, you know, he's not real tall, but he's a pretty big guy nonetheless. So we'll just say 100 kilograms. That's probably a bit of an overestimate of his actual mass, but let's just say 100 kilograms to make the numbers easy. All right, so that's my initial state. Now, in my final state, if you watch the video clearly, you find that the ball actually stops. So the final velocity of the ball equals 0. And White Goodman falls down. He has a certain velocity. And the final velocity of White Goodman is, well, he covers about 2 meters. He's knocked back about 2 meters in about 1 second. So we'll call that about 2 meters per second. That's a pretty good conservative estimate, just based on estimates from the clip. Okay, so now we want to say our initial momentum equals our final momentum. Initially, only the ball has momentum. All right, so White Goodman has 0 momentum because he has 0 velocity, so I'm just not even going to write that. In the final state, only White Goodman has momentum. Because the ball actually stops. So I can put in our values, our estimates. We had a half a kilogram times the velocity of the ball equals 100 kilograms times our 2 meters per second. So I get 200 on the right-hand side, divide by a half. I get an initial velocity of the ball of 400 meters per second. Now, just for reference, the muzzle velocity of a handgun is about 300 meters per second. So this is one heck of a fast dodgeball coming off of his hands. It's 400 meters per second. All right, you have a quick test question. So this is a similar setup, only in this problem, the ball has a more reasonable velocity of 10 meters per second. I just want you to find the final velocity of White Goodman. You follow the same procedure, you're just looking for a different variable. So go ahead and try this quick test, and you'll see that on the online class participation quiz. And we will pause and come back to types of collisions, which will be the last topic in this chapter in just a bit.